I want to get into an in-depth review of what you can expect tomorrow. Because I think some of us got caught off guard with the quiz this year. All right. I'm not saying you didn't take it seriously. I just think you thought it was going to be easier than it actually was. So let's not let that happen again. Full unit test tomorrow. 33 points if you want to know. All right, let's start with the basics here. Reflections. Can you reflect over any horizontal or vertical line? If you don't know what the equation is or what type of line it is, graph it tomorrow, please. Graph it tomorrow. All right, so if you don't know what y equals 6 looks like, throw it in the calculator, take a look at it. We're all good there. All right, just a heads up, I am going to have you find the line of reflection given 2 points. Your quiz, let me show you what I mean here. Edit. How about a grid? There we go. On your quiz, I gave you what point A was, and I said, hey, reflect it over this diagonal line, and you told me where A prime was. Tomorrow, different story. I'll tell you where A prime is. What line did I reflect over? And what's the line of reflection the same as? Perpendicular bisector, correct. So you need to find the slope, negative reciprocal, midpoint, and then do point slope form or slope intercept. So that's what I'm talking about here with find the line of reflection. Okay. Remember we did constructions with reflections. I'll talk about how many constructions will be on the test in a minute. So we did constructions with reflections. Translations, function versus vector notation. Some of you guys got that incorrect on your quiz. Highly recommend you look back at that. Construction using translation. Okay, we did constructions using translation and a vector. Rotations. Rotations, make sure clockwise. Are we still having issues? Counterclockwise versus clockwise. With dilations, dilate a line. That was last night's assignment. Dilate a line. If the center's on the line, where's it go?
It stays
nowhere. Stays right where it is, right? And if the center's not on the line, it remains parallel with the new y-intercept. Compositions, just a reminder, compositions. I'll do a reflection of y equal over the x-axis composed with a rotation of 90 on triangle ABC. What gets done first? Whatever's to the right gets done first. Whatever that point is, I keep proceeding to the left. All right. All good? Next thing.
Wait.
Yes, Zach.
So, if that little circle is there, then you know it's composition.
Correct. That's the symbol for composition, which means I do whatever's to the right first. Take that triangle and keep going to the left. Next one up. This is going to happen again. Prove 2 triangles using rigid motions. That's where you guys figure out how do I get ABC onto A double prime, B double prime, C double prime. And then you write that little statement, hey, reflections and rotations are rigid motions, which preserve side length and angle measure. Ergo, 2 triangles are congruent. Okay. Please, this is probably big for some of you. There's only 13 questions, and the first 9 are multiple choice. So you might want to take your time on those. Okay, 18 out of the 33 points tomorrow are multiple choice. So you might want to take your time on those tomorrow. Okay, because that's a majority of the test. Next up, what are invariant points? Because I'll ask a question there. Connor, invariant points?
Points that don't move in transformation.
There you go. Points that don't move. So I reflect, rotate, translate. Points that do not move. Okay. Same versus opposite orientation. What's the only one that results in opposite orientation? Reflection, correct. A line reflection. And you will need the distance formula tomorrow. Heads up with that. Okay, you will need the distance formula on one of the questions, so that I will not provide that, as you know. And here's the probably the bad news. There's only going to be one construction. And what do you have to choose from? Reflection, translation, dilation. One of those 3. And no, I will not tell you. Okay, and one of those three will be the construction. And then finally, I'm going to ask how many degrees does a figure to carry it onto itself? Just a reminder, let me use one that won't be tomorrow. That's a regular pentagon up here, kids, regular pentagon. How do you find the number of degrees so I get that same looking pentagon in that same spot of the television again? How many degrees would I need to rotate it so I get this pentagon in this spot back? 360 divided by 5 rotations, good. So 72 degrees. Is that my only answer? No, that's the minimum amount I could rotate from this vertice to this one. How do you figure out other degree rotations?
Multiply 72.
Keep doing multiples of 72, right? 144 and then whatever is after that. Finally, I know this is a pentagon because I have it up here and it's got 5 sides, but I believe this is a multiple choice question. So make sure you know if I say 6 sides, what we're talking about.
Hexagon.
Yep. 8,
Octagon.
octagon, 9,
Nonagon.
nonagon, and then 10,
Decagon.
decagon. Okay. Because I probably will not have it drawn. So you're going to have to know, oh, nonagon, 9 sides, decagon, 10 sides. Okay. Questions? Going. Unfortunately, I'll be here after school today, but I got to leave at 2:30. Okay, so if anybody's coming by. Okay, let's talk review. No extra Delta Maths or anything on Classroom because you have a slew. I don't know how many, I didn't count them, but there's a ton of review questions in your packet right now. Okay, and that's what we're getting done. Anything on the topics? This will stay up on Classroom. Anything on the topics from you guys before you start getting after it here? All right, close up the Chromebooks. Let's get it going. You want to move? As long as it's on this, it's only going to take me one opportunity to move you.